So this example 1 is the example where sign of all these three quantities, object distance, image distance, and the focal length, they are all positive, as you've seen with the numbers here. So let's just use that as a starting point, and I will try to describe when they may become negative. So object distance, image distance, and focal length. And I will try to spell out the conditions under which they are either positive, which is what we are seeing right now, or the conditions under which they are negative numbers. Okay? I guess I think we might have enough information to say when the image and the image distance and focal length are positive. When would you say focal length should be positive? Like, what do you know about this arrangement that would be different from the other example that we looked at last Thursday?
It's a converging element.
Yeah, converging. Sorry, it was a bit of a vague question. It's a converging lens. So when you have a converging lens, it could be done by, some of you are asking about concave, convex last time. There's a reason I stay away from concave, convex terms. Because here, it's the convex lens that gives you a converging configuration. When you're dealing with the mirrors, it's the concave lens that's a converging mirror. So I leave it up to you to figure out that a setup is converging or diverging. Once you know it's converging, that gives you the sign of the focal length. So you get a positive sign whenever it is a converging optical element. This is true if it's a lens, true if it's a mirror. As long as it's converging, it's positive. What about the image distance? When should the image distance be positive? Or, it is positive here now. So what would you point to and say this is why the image distance was positive? Image is further away than the focal point? And now the object was, but object was farther away than the focal point, but I don't really want to use that because I'm looking for a condition on image, so I only want to refer to the image. If I have to refer back to the object, it's going to go through some layer of calculation. I don't want that. I only want to look at the image.
When it's real image?
When it's a real image, that's one way of saying it. All right. So let me ask you this question. How do you know when an image is real?
Because we only deal with several situations, so we can have a feeling about it when a converging lens from imagine.
All right. Let me move on to my next example. I think I'm asking a question that no one here is ready to quite answer in a way that's satisfactory to me. So let me move on to the next example. Then we'll be able to clarify when we know an image is real. Yep. So we'll come back to this in a bit. So for now, real image, sure, that's fine. It's better than blank.